Power over Ethernet is everywhere. Matter of fact, you want to see? Welcome to my backyard. Power over Ethernet literally lives everywhere here. Let me give you just a few examples, right? As you can see right here, swimming pool, right? Kids often swimming and their friends are over, and my wife said, what if we could have a camera? And so my son and I actually got up and installed a IP surveillance camera sitting up there, no power attached outside of the network cable. And it's that network cable right there that is literally delivering the power over Ethernet, right? What else? Well, take a look right here, little Ramada, right? Behind this television, I don't know if you can see it on the wall, is a wireless access point. Let's see if you can see it inside of there. Right up at the top of that television, powered by power over Ethernet. On that television is a little widget that allows it to get television stations, etc., stream from the inside. Guess how that's powered? Power over Ethernet. Everything's coming in with power over the Ethernet cable. So as you can see, power over Ethernet, it's everywhere. And that's literally just in the corner of my backyard. Imagine an enterprise business and all the places it's used. So by the time we're done here, we will examine the purpose of power over Ethernet, which you're already getting a sense of, and the key technologies that make it possible. So, flyby on the purpose. Power over Ethernet is the ability to deliver power over the same Ethernet cable that delivers your data connection to all of these attached devices. Now, I'm putting the most common ones right up on the screen right now. Cameras, wireless access points, IP phones. I'd say that encompasses, at least today, probably 90% of the devices that we use power over Ethernet for. However, as the standards keep evolving, which I'm going to show you in another video in this skill, the power that we can deliver keeps going higher and higher to the point where we can power small computers over power over Ethernet. As a matter of fact, I just got one. It just hit me. They have PC sticks. I don't know if you've seen them on Amazon or some other place now. That literally a PC in the size of a stick that you can just plug straight into the HDMI port on your television. Well, the beauty is you can actually take that and power it. Most often it's powered via USB, but they also make some that are powered by power over Ethernet connections. So the Ethernet cable into that PC powers it. And the advantages are a no-brainer. Central power, you don't have to buy AC adapters for each one of those. Central backup, I mean, if this is a critical device, I mean, imagine having to put an uninterruptible power supply, the battery backup, to each one of those. Why not just have the switch, the same network switch that is providing the Ethernet connectivity, and just provide a UPS-powered backup for that? Then if the power goes out, this guy is already trickling power to all of these devices so that you don't have to worry about them going offline. So how does it work? Well, the first thing that you need to do is ensure that you've identified what kind of power source you would like to use. There's two major types. A PoE switch, which if you're one of the people that like to talk the technical terms, it's called an N-span device. And that's, by the way, if you go to the PoE standards and open up the white papers, they go, okay, you've got an N-span device, which is the switch that's sitting at the end of the line, essentially, where most of the lines terminate and provide the power. Or you can get a power injector. What kind of emphasis was that? A power injector, right? Because it's injecting into the line. And if you take a look right here, this is a mid-span device, and that name so accurately identifies it. So let's just say you don't have a PoE switch, right? And you've got that cable. You don't want to replace your entire switch for maybe just a couple devices. You can purchase these little mid-span devices, which plug straight into a wall-powered outlet, an AC power outlet, and they take the LAN cable, you can see that's coming in right there. Shoop, it's even labeled LAN right on the device. And then inject power onto the line, and the output is PoE. So you can attach your wireless access point or whatever you've got that you're plugging into that cable to receive it. By the way, just because you don't need a mid-span device now doesn't mean you will in the future. And the only reason I mention that is I just took you out to the Ramada right outside, right? I ran out of PoE ports on the switch that actually ran out there. I had to split it off when I got there. And there wasn't enough power to reach every single one of those devices. So I don't know if you saw it. If you want to, you can rewind the video. Dangling, just because I haven't mounted it yet, dangling right in front of that wireless access point, you can see one of those mid-span devices. Here, I grabbed a picture of it just so you don't have to rewind. I don't know if you can see it right here. I'll outline it in red because it's all shadowy back there, right? That right there is a midspan device. It has a plug that goes into that little, it's a mess, but I got to clean it up. But right here, this cable is the one that I ran to that IP surveillance camera right there. That's the PoE end of the cable. And this one right here goes into the network switch where I didn't quite have enough power to deliver power over Ethernet without that midspan injector. Now, when Power over Ethernet first came out, there was a lot of people that are like, oh no, we're going to cook our devices. If we plug a device in, it's going to be like, bzz, and, fry the network card and catch it on fire and everything else. I heard all kinds of crazy stuff. That's not the case. A power device, which by the way, this is again to the official spec. That's what they call it. These are all PDs. A power device is detected using a fast link pulse. You can think of that like a tone sent on the cable, that if that tone hits a powered device, meaning something that needs power, not literally it has power, a power over Ethernet device, that device will be equipped to loop the tone back and tell the switch this is a device that needs power. It's at that point that power is delivered and power negotiation occurs. Now, we've evolved over the years. The original 802.3 AF, which actually there were even standards before that. Cisco came out with proprietary inline power. That's what they called it, inline power, before there was a standard. And they had their own method of detecting. But in the original industry standard one, which was 802.3 AF, that's the specification of it, it would send that pulse to negotiate the power. As soon as it realized that it was a device that needed power, it would power it on and then try to identify it using a pulse of one of three different types of power that's being used. There was actually three different classes. See, the original 802.3 AF could only deliver 15.4 watts over the line. Now, that's enough power to power a phone, a small wireless access point. The wireless access points we have nowadays need a little bit more power most of the time than the original 15 watts, and a small surveillance camera. But again, the surveillance cameras we have nowadays typically require more power. Some of them even have motors that can turn the camera and things like that. So the more functionality that you have, the more power is required. Well, the challenge is that we don't want to burn out the power supply in our switch, meaning exhaust it. So they needed a method to say, how much power do you really need, device that is plugged into the port? In the original standard, they would detect that using a type of pulse. And if you were a friendly device that would send that pulse back, you could identify yourself as one of three different classes. That tells the switch how much power maximum you would require. See, here's the challenge. You might have a switch that doesn't have enough power in its power supply to deliver the full 15.4 watts across every single one of the ports, right? But if the device doesn't tell you how much power it needs, then the switch has to budget as if that device could use all 15.4 watts. And by the way, you notice I have on there sorta. Well, that's because in reality, it's only about 12, 13 watts of power that make it to the device because of the loss that occurs over the Ethernet cable. So you're never getting the true 15 watts that it could potentially send. But regardless, if the device didn't talk back, then the switch had no choice but to say, well, then I'm going to provision the full 15.4 watts. It wouldn't be an accurate measurement to say, well, you're only using 7 watts right now, so I'll provision that, because what's to say the device couldn't suddenly be like, I need 10. And if you get what I mean, right? So that negotiation thing became a thing. It became a big deal. And later on, as the standards evolved, they created Link Layer Discovery Protocol, which is, by the way, the industry standard CDP, Cisco Discovery Protocol. The industry caught up, and that is used to negotiate a lot more granular levels of power than the three big classes of power that are there. And again, I'm talking so much stuff right now. Just know, step 3, you negotiate power. We'll talk more about that later on and the different increments that can be used. Lastly, once it knows how much power to deliver, it will send the power originally over the non-data wires. That is, when you look at an Ethernet cable, the send-receive pairs use 1, 2, 3, and 6. So 4 through 5, 7, and 8 were used to deliver power because that wasn't used for the data. And the original power standard would interfere with the data. Later on, they figured out how to deliver power over all 4 pairs, so over all 8 wires, to up the power budget that we could actually send. So hopefully that cram session is what it kind of felt like there, gave you an idea of the purpose of Power over Ethernet and the key technologies that make it possible. What we're going to do now is unpack those as we look at the different standards that have emerged over the years, and then get into an actual Cisco switch and see how it projects and reports what Power over Ethernet is being used. I hope this has been informative for you, and I'd like to thank you for viewing.